lecture is on combined units. Combined units are derived from the standard units. The standard units are given as length, mass, and time. The dimensions of those are capital L for length, and capital M for mass, and capital T for time. And those are in meters, kilograms, and seconds. Our first combined unit is area. Area can be found as a length times a length. And therefore its dimension is L squared, and its units are meters squared. Volume is found as a length times a length times a length, and therefore its dimension is L to the cubed, and its units are meters to the third. Density is given the Greek symbol rho, and is found as the mass divided by the volume, and therefore its dimensions are mass divided by L to the third, and therefore it can be written in terms of units, kilograms, meters to the third. So continuing on with our combined units, we have three new ones we're going to look at. Let's begin with velocity. Velocity is defined as the length divided by a time, so its dimensions are L over capital T, and therefore have units of meters per second. The second is acceleration. Acceleration is defined as the velocity divided by the time, and therefore would have units of length over time, which is velocity divided by time, which is equal to length over t squared, and therefore has units of meters per second squared. The next one is force. Force is equal to the mass times the acceleration. And so that's equal to the mass times the length over the time squared, which gives us units of kilogram meters per second squared. Next, we're going to take a look at an example of two other quantities that can be found from combined units. So now, as an example, let's complete the table that's shown below. So the first line is the force, and the force, as you recall, is equal to the mass times the acceleration, and it has units of kilogram meters per second squared. An impulse is defined as a force times a time, and so its dimensions would have the dimensions of force, which are mass times length over time squared, times time. So we see we have a time in the numerator and a time squared in the denominator, and we can cancel those two out. And so the units assigned to the impulse would be kilograms, meters per second. The next one is pressure. Pressure is defined as the force per unit area. So again, we have the dimensions of force, divided by area, length times length, or length squared. And so the units assigned to that are going to be kilograms. And since we have two lengths in the denominator and one in the numerator, we'll cancel those. And we'll be left with a length in the denominator, which is in meters, and time squared, which is seconds squared. So the units of pressure would be kilograms per meter second squared. And that completes the example.